Hello, and thank you for joining today's webinar on AI moves fast. Your validation process has to move faster. Before we get started, just a quick introduction to me. I'll be your host and presenter for today. I'm Bruce Cullen. I'm Director of Products and Community here at Workspace DNA. And you've got me because I'm the guy that's ultimately responsible for our AI bits and pieces, including ATP 360, which is going to feature later on in today's webinar. Hopefully, you can't hear the cats shrieking at me in the background. That is the downside of a live webinar, but we're going to go on anyway and introduce my moderator for today, Misty Scott. Misty is Chief Marketing Officer. Hey, Misty, how you doing?
I am great. I'm excited about today's content. I think it's going to be pretty freaking cool. So,
I mean, I'm biased, but so do I. I think it's going to be great. Misty's going to help me out with Q&A at the end. So if you have any questions at any point, please do just keep them coming. We'll take them all at the end. No question is too big or too small. All right, let's get into it. So I'm going to do a little bit of scene setting to start with by talking about what is the problem here? What are we even talking about? Why do we need to go faster with our testing, essentially, with our validation? What it all comes down to is vulnerabilities. And to introduce vulnerabilities and why this is sort of so important, we're going to look at the new threat clock. What is happening is AI is getting better and better, and it's being used to find more and more vulnerabilities. So this line chart here looks at CVEs disclosed per year, and this is from data from CVE.org. And the first three data points, the first 3 years, 2021, 2, and 3, essentially the number of vulnerabilities discovered goes up by about 5,000 a year. Now, the first thing to note is this isn't a flat line. This is pre-AI. It's still going up effectively. That's noteworthy. So we're fighting against a wave of more and more vulnerabilities to kind of start with from the perspective of an enterprise. But then 2024 comes, which is probably about when we got the first real AI that you can actually use for something useful. And you'll see there's a jump in this number going from 29,000 to 40,000, about 11,000 more. That is a significant number. Now, I'm not saying this is all down to AI, but it certainly plays a part. And then in 2025, this jump goes up again when we start to talk about increased AI. We have an additional, what is that, 8,000 there. But then at the end of 2025, we have the birth of the Mythos class of model. So we're not talking about sort of things you might use for everyday things. We've got Mythos, we've got M dash, we've got Fable, we've got models of that class. They're frontier models, and they are very, very capable. And on the release of Mythos and a bunch of models like it, First, who are another organization, made a prediction that for 2026 we'd be looking at 66,000 reported CVEs, which is absolutely mental. Bear in mind, 5 years ago we were talking about 20,000. I mean, that is a massive increase. And the thing that makes this even more wild is it's wrong. It's too small a number. In the first half of this year, 46% more vulnerabilities have been found than this prediction would indicate. So we're on track to beat this number, which is just wild. And we've also got some really big kind of like organizations using AI to actually find these vulnerabilities themselves. And they've published some bits and pieces on their own findings. So Mozilla, the company behind Firefox, they have their own internal CVE numbering authority. And in Q1, they attributed a 146% increase in CVEs due to use of AI tooling. It's a wild percentage increase. And Apache, similar kind of story. They were a Glasswing participant. Glasswing was the preview program that spawned Mythos. So this would have been in sort of probably late 2025. And they reported 170% addition in CVEs. Again, just wild stats. And the other thing that's really interesting about all of this is it's not just finding more in quantity, it's also finding these weird, dormant for decades vulnerabilities that have been there for literally decades. I mean, a 30-year-old vulnerability, the fact that this hasn't been sort of disclosed, it could have been exploited in the past. Just because it wasn't sort of disclosed publicly doesn't mean someone hasn't tried it and didn't know of its existence. So these are things that have survived reviews by trained humans. They've survived fuzzing testing, security scans, and bounty programs, and are still there to this day. And AI is finding more of these sorts of things. What I'm really saying is AI is really changing the game as far as discovering vulnerabilities. Back in the old days, this would have involved a human like me sat in front of a keyboard. Yes, they would have had tooling. Yes, they would have had automation. But ultimately, they're able to find vulnerabilities in minutes to hours with these frontier level models without necessarily even having the bit of software in front of them to run against, like they would have had to have done. Um, Now, this sounds like bad news, and it is bad news, but it's not the end of the world. And the reason why is ISVs, software companies ultimately, have the same frontier models. So they can patch as quickly as the bad actors can discover. So there's some good news. So why are we having this webinar? What is the problem? Well, the problem is, sadly, your problem. If you're somebody who's responsible for managing all of this change, if you're still running a process that takes weeks to validate a patch, you're looking at monthly patch cycles, that kind of thing, then simply, you're not going to be able to go fast enough to keep up with all of these patches. Now, this isn't a completely new problem, let's be honest. We've had vulnerability backlogs for quite some time, but there is a side effect from this increase in the velocity, the rate of change here. And I'm going to use an analogy to help me explain it here. We're going to use your favorite fast food takeaway joint, basically. Back about sort of what, 5, 10 years ago, you would have gone to the counter at the restaurant and asked, had a look at the menu and ordered something. And then you would have stood in a physical queue and waited for your food to be cooked. But you would have had a visibly obvious physical queue of people waiting to collect their order as it's being cooked. And this is a problem the fast food industry is in part tackling with the ability to order ahead on an app. So I can sit at home and I can put in my order on my phone. And then when I'm getting close and I'm just around the corner, I can say I'm ready to collect. So that in theory, when I walk into this restaurant and I say, hey, this is my order number, the food is sat there on the counter, I can just grab it and go. That queue has been eliminated, that bottleneck has been removed, at least reduced. And it's a really similar analogy here in software when it comes to validation. If you've got a large queue of untested patches sat there waiting, you are building up a queue in just the same way as in the old world at your favorite fast food place when you're ordering at the counter. I'm going to use a sort of visual example of what this kind of looks like with increased discovery of vulnerabilities and increased release of patches in the second column here. With the same sort of velocity of testing, we're building up a bottleneck of things that need to be deployed, and they're just sat around waiting effectively. Now, I've seen companies go, well, look, let's not test. Let's just deploy stuff. Because then, we patch the vulnerabilities. We're not going to get ransomware or attacked or whatever. And that is true. But it causes another problem, which is what you see in this slide, which is while you are no longer vulnerable to the attacks in those unpatched CVEs, you're breaking things in production. And this is a problem that is only going to get worse. Because the reality of this is, with increased change comes increased risk of breaking stuff. Because there are always going to be dependencies between apps and between your OS, your environment, and the applications themselves. This is how it tends to work, sadly, when you skip the testing piece. And there's another side effect, which I've kind of touched on already, which is this. We've had an increase in the number of vulnerabilities found for a long time. Even pre-AI, these first three data points, it was still creeping up. And no organization that I've ever sort of spoken to has no backlogs. They always have something. And this sort of tidal wave of increased detection of vulnerabilities means you've got an even bigger backlog now to have to deal with. And so it's either going to get worse and companies are more exposed, or it's going to get better, but they're introducing themselves to greater risk, or they fix the validation issue and solve this issue once and for all. The other very important point to kind of touch on here is what we at Workspace DNA call the ripple effect. This is the knock-on effect of a change affecting something else. And for this, I'll use this. Imagine throwing a stone into a pond on a calm day. You see a ripple effect spreading out from where that stone hits the water. Now imagine that stone is your patch. This might be a single app, that you've patched to patch a CVE. From this point onwards, the security team is happy because from their perspective, there's nothing to nag you about. The CVE is dealt with, but you have a knock-on effect. This patch may or may not shift application behavior, how the application you've patched sort of behaves. And there's sort of a few interactions there between the application, maybe dependent applications, and maybe the environment it runs in itself in the workspace, that ultimately can lead to user disruption and ultimately to business impact. Now, when we're talking about a single patch to a single app, you can see the ripples. They are visibly obvious in the case of my stone going into a pond. Now, when we move our patching cycle from a monthly cadence, we can see the effect. It's slow and we can watch it. We know what broke, when something does break, what the cause of that breakage was, because we're controlling the change by using slow speed. In an AI era, we haven't got that luxury anymore. We just have to patch these vulnerabilities because being vulnerable is clearly something that is very undesirable to your C-suite. And you'll end up with these sorts of ripples. We've got these three changes here potentially impacting something in the middle here. So if there is a breakage, which of the three changes that touches on this thing is the cause? It's really hard to unpick and to find out. And sadly, for enterprises, big and small, this is coming. This is our reality right now. Because whatever you think of AI, it is here to stay. The genie is out of the bottle. There's no changing what is sort of happening out there. So really, the only real answer is to kind of be prepared for it. So I said a lot here that says this problem is all about speed of testing, and there is some truth in the fact that it is about speed of testing. But there are some other dimensions to this problem. We have the depth of testing problem. Now, traditional tooling is all about testing the app installs so that you can open it. And that's a good start, but it's certainly not nuanced and deep testing. A good example of this I got from one of our customers recently, where they rolled out a new version of an app that had they used in a workflow that had print to PDF functionality, and the app itself worked. It would have installed, it would have opened. But print to PDF was broken, and the knock-on impact was the department that relied on this functionality for invoices, saving invoices as PDFs, couldn't ultimately function. So the lack of depth of testing was the problem there. We have a similar issue when it comes to breadth of testing. I see two different patterns out there. I see teams that have a dedicated test group that are responsible for functionally testing applications. And I see the app owner model where somebody from regular business is responsible for testing new versions of applications. And they both fall down because they do not scale infinitely. Typically the app owner doesn't care about testing. They don't want to know fundamentally. So, if you're getting them to test more, either they're going to test at the same rate, or they're going to switch off and you're going to have a breadth problem, which leads to, well, let's just test the 10% of most important apps. We won't worry about anything else. Well, from my previous slide, you kind of know where that's going to lead you. And then, of course, with this accelerated change, we've got the ripple effect, which we've already kind of talked about. So those are the three issues that I see that I hear from our customers on calls. So this is where ATP 360 comes in. ATP 360 is your agentic application owner designed to create test cases, structured test cases, and also execute them from something really simple like a prompt, from a video, or from a document. So the whole premise of ATP 360 is this. I'm not going to bore you with any more slides. We're going to jump into a demo of ATP 360, which is what this is right now. And just to sort of set the stage here, I'm gonna assume the role of somebody working in an insurance company who has two really important but really legacy applications. This is a fictitious insurance company, by the way, so I'm not, these aren't real apps, this isn't real data. They are genuinely old and real applications. And they're built around .NET 4.8. Now, this is one of my applications. This is my Claims Manager app. So we're looking at good old-fashioned win forms. You get an idea. This is the application that new claims for my property insurer are input into. It has sort of reporting capabilities. It can report to Excel, and will use a workflow that spans multiple tools. So this is installed locally to my laptop, but this is would obviously in real world not be, but you get the idea. It's old and crusty. And then we have the change. Now, in this case, the change is not to the application. This is a Microsoft KB, so a patch for .NET that was released really recently. I'm recording this on the 26th of August, and this was released on August the 11th. And it changed some stuff in .NET. I don't know what the stuff it was that had changed, but the point is, I need to make sure that my old claims department app and another one I've got around the accounts department still work. And that is the background at which we step into ATP 360. Now, on the Test Now tab over here, I can provide a document, a video, or a prompt to generate test cases. And for my demo, I have a script, test script, which is just a bit of text that has gone out of Notepad here. And I'm going to get this converted into structured test steps. If I'd have had time before, I would have recorded a little simple video, basically, of me talking through testing this application manually, which I would have fed in. I love to give that as part of this demo because if you've got the app owner model and they're really hard to get hold of, get them on a Teams call. Record the Teams call and get them to show you what the application does and what it doesn't do, and feed that in because that will result in the same kind of thing. You'll have structured test steps, which this will spit out very soon. Here we go. And this is sort of repeatable, therefore, and you don't need the app owner by this point. This is a functional test. Now, the test I've defined here, the first thing it's going to do is open PowerShell and check that this KB is actually installed on my test device. We're then going to launch my second legacy app called Accounts Receivable, and we're going to log in. Now, the login stuff is particularly cool because obviously this is AI, and from a governance perspective, nobody wants to give AI credentials directly, and with good reason. So we effectively abstract away the credentials from AI. AI will do the driving of the computer to run the test. It will focus the right boxes and then hand over to good old deterministic algorithms to insert the credentials, which are stored and are transmitted securely. So, in this case, we might select pre-existing credentials from our vault, or we can input them afresh. And the same would be true with the password. You get the idea of what this sort of test looks like. At the bottom, we have structured pass-fail criteria, so you can see what good looks like. And if this isn't right, you can go back and iterate over what you provided. I'm going to run a pre-existing version of this test over here because I don't have the time to read all of these steps in front of you right now. Oh, that's the same one again. Sorry. This is the one I made earlier. Effectively, it does the same. I'm going to select where I want this test executed. Now, this isn't going to work particularly well because of virtual backgrounds, but I'm running the tests on this physical laptop that's sat next to me on my desk. The thing you test on can be physical, it can be virtual, it can be whatever you want. And I'm going to go down to the bottom and say, I want the saved secrets that were saved with this test used. And I'm going to kick off testing by hitting test now. And the test will start more or less immediately. Now, when we're watching a test be executed, down the left-hand side here, we have the test steps. You can see the test step that's in progress. You can see when they're passed or failed, they get ticked off or crossed off, depending on whether they pass or fail. We've got our success and fail criteria at the bottom here. And these are sort of, once you've seen the steps, you can move them out of the way because it's probably quite useful to have this space to see what's going on with the test. And down the right-hand side, we have the action log. Now, the action log is super important because this is effectively your audit log. This is the what did AI actually do and why did it do it? And we expose a certain type of message from that only in the UI, but we make everything that we did, the coordinates we clicked on, the logic, the reasoning behind each decision. We expose all of that in a downloadable report, which is then passable to make into reports for your boss. So the first step was to check for the presence of this KB. So we're firing up PowerShell and we're checking that this KB is present. And you can see from the looks of things that it is present. So I'm expecting it to pass step one and to then move on to step two. And when it does that, what I'm going to do, just to prove it will do this, and it has done, is it's going to fire up my accounts receivable legacy application, and it's going to log in and it's going to check that it can see and access existing invoices. It's going to check whether it can add a new invoice. It's then going to generate a PDF of an invoice. Now, for a typical accounts team, this is critical because the thing that they actually send to their customers is typically an invoice in a PDF form via email. So that is the flow that this will sort of execute. Because I haven't got forever to do this demo in, I'm going to look at my existing test results over here. Going to pop open a new tab. We've got the existing test in progress here, and we're going to look at here's one I ran earlier test, which we can see. So this test passed, all of the steps are ticked off, but we can see the detailed actions down the right-hand side. And we're going to, let's scroll to the top to start with, rather than starting at the bottom. We're going to get to the point where we're in the accounts receivable tool and we've logged in quickly. So let me just tab through. You'll see from time to time it will zoom in on a piece of UI. This is good because it means it can get a better look at what's going on screen, allowing for a better resolution. So here we go. This is our .NET 4.8 app. This is the thing we want to know whether the KB in question broke, and it loads. That's a good start. And we can see that it's editing an invoice here. It does seem to be working. It's zoomed in on an invoice. Fake data again, 100% fake data. It will then hopefully try and create a new invoice, which it's doing. I'm quickly just flipping through the action log down the right-hand side to speed things up here in replay mode. And it also then tried to test the export to PDF. You'll also notice that each of the actions is tied to a test step, which is kind of great for auditability. The PDF was generated, and there it is. It looks okay to the eye, but the test was, do the values match? And in this case, it zoomed in on the values to check that they match, and they do. You get the idea for what this is and how this kind of works. The point here fundamentally is that this is not a modern app. This is running on Windows 11, but only just, and it's very susceptible to change. The second piece of this test, after the accounts receivable one, has reporting that, let me just remind myself what test step it is, where we log into Claims Manager, step 11. Let's find step 11. So we're logging into Claims Manager, the second application now, and let's just get it logged in, get past these steps, and we're looking at a list of claims. Now, in the Claims Manager set of tests, very similar sort of thing, we're opening tests. But the thing that gets interesting about this one is that the reporting functionality in Claims Manager is not an on-screen report. It's an export to Excel, which I'm going to skip to. So reports export to Excel, you'll see in there. So the test here is that interaction between two different applications, much like with the save to PDF case. So when you go export to Excel, you're asked to pick a bunch of parameters, and the test was asked to, what type of report was it again? Claim value over time reports, export claim value over time, this bottom button here. And so it should do this. It then saves the Excel file. Now, here's an interesting point. This file already exists because clearly this is a demo and I've run this demo before. So in this case, AI had to make a choice as to whether it replaced the existing file or created a new file name. What did it choose to do? It decided to, what did it do? Let's read the message. Do you want to? I'll click yes to overwrite with the freshly generated report. So it made a choice there. Now, the reason why it's important to have this level of auditability is sometimes AI is going to make decisions that you don't like. And this is important. We'll come on to this in a second. I'm just going to quickly show you the report in Excel, which looks like this. So the use case here in the real world where we got this example from is that this would then be emails to the boss of the department effectively for weekly reporting, monthly reporting kind of use cases. And that's the gist of the test. So we've touched on two different applications. We've touched on them on top of an updated version of .NET, which is a dependency for these legacy applications. We've got a multi-app workflow running here. But the thing that's really important here is the test passed. Now, if you don't like the fact, let's say you don't like the fact that it overrode a file here, overwrote a file, you can actually override this result, which I can do here and say, well, why did I override this result? AI deemed it passed. And we could say AI misjudged the results because it shouldn't have overridden the file. Um, existing file shouldn't have been overridden, overwritten. Sorry, you get the idea. This piece of data then is saved. The result is flipped to fail, and in our AI efficacy tab, we can see the effect of our results being overridden over time. We can see what has been overridden, which is great for auditability. Ultimately, this data will then be used to improve the model and make ATP 360 better. And that's the gist of ATP 360 at a really, really high level. I'm just going to go back to my live test just to have a one quick look at what it's doing. So we're now on step 9 here. And the thing to note is this test's been running for what, 7 minutes? We've got through steps 10 of 16 and we've spent $2.50. So very little money has been spent. We spent a lot of time optimizing kind of token use to be very efficient with how we interact with AI, because it's a tool to be used sparingly and where it makes sense, if it were to be costing too much. We're going to leave this test to run and we're going to go back to slides and then see if there are any questions, because otherwise I won't keep this webinar to the time I have to keep it to. But you get the idea for how ATP 360 works. So the three main takeaways from today's webinar are discovery of vulnerabilities got faster. And so patching has to get faster too. You're going to be facing more change more frequently than ever before. And this volume, the sheer velocity of patches, patched apps from your ISVs you're going to get, the more likely you are to find breakages or to go slow and to leave yourself exposed. So you've got either risk in the form of vulnerabilities or you're exposing yourself to risk in the form of broken production. Now, we don't want either of those things, of course. So the question was never about whether you can patch, because clearly you can patch. It's whether you can test enough before the risk in the vulnerability becomes reality. And those are the main takeaways from today's webinar. So without further ado, I'm going to turn it over to Q&A, and that's why I'm going to need my glamorous assistant, Misty, to tell me if there are any questions in the chat, and I'll take them as they come. So please do send me any questions you have. Thank you.
Glamorous. That's very nice of you, Bruce. So I do have a couple. And ladies and gents, if we don't get to it, I will email you and just get you connected with the right person with the right answers. But we do
Mhm.
have some good ones here. How
Mhm.
many out of band patch cycles do most organizations have to cope with today?
Out of band patch cycles.
Yes.
Oh, see, the thing when you say today is we're now living in a world with AI, and the real answer to this is it varies so much organization to organization because of their processes, basically. Some organizations that we come across, some companies still run a monthly patch cycle, but they also admit they have a large backlog of vulnerabilities effectively. We do see organizations that take this the other end of the spectrum and they use our tooling and they patch daily effectively when there is something to patch as soon as they validate that patch and can prove it's not going to break things. So the answer is sadly it depends type answer, but there's your answer.
All right. The next one, what are you seeing as the typical SLA today for the in-band patching, like the weekly, say, Patch
Hmm.
Tuesdays?
Patch Tuesdays. So, because of the validation piece, typically what we see when we start these conversations is all the validation piece is done manually. And so, because of the risk aversion in the sorts of organizations that we speak to, because they need the assurance this thing is going to work, they're looking at a 2 week, 3 week sometimes cycle between something appearing that they could roll out and them actually doing the rollouts. And they're all looking for kind of like, how do we speed this up? So that's the typical cycle I see.
Yeah, and it's compressing, right? I mean, as far as all these mythos and stuff, we're probably getting down to hours at some point.
Well,
Uh,
it's going to have to go that way. But what it comes
yeah.
down to is you either compress the cycle and make it quicker, and reduce your sort of vulnerability backlog, and either take on the risk of not testing, or you devise some testing approach that can keep up. And so we typically see companies going from the 2 week, 3 week mark down to daily, with tooling like ATP 360.
All right. And we're right at time. This is a good one here. Can you test multiple impacts at once?
Can you test multiple impacts at once? Yes. Multi-app workflows are very possible. At the end of the day, because we're driving a GUI, if you can get at it via a GUI, then it can be tested. So 100% yes.
I love it. All right, so I'm going to close out with a gift for you all for joining us today. If you'd like to run ATP 360 in your environment, I have put the link in the chat. Super
Mhm.
easy to remember. It is workspacedna.com/ATP 360. You can also reach out to us individually. We'll get you connected, get things rolling, and get you guys all up to date and validated. I want to thank you for your time today. I hope it was meaningful and impactful for you and your businesses. And we look forward to seeing you on future webinars. Have a great day.
Have a great day. I'd love to hear feedback on it. As a product guy, genuinely not here to sell you this. I want your feedback. Does this work for you? Doesn't this work for you? So I'd love your feedback and love for you to all to try this. Thank you very much. Have a good day.